Alrighty, welcome everyone to day 10 of Advent to Code. We're here today representing my Columbus Crew jersey because I just won the MLS Cup today, but stay on topic. Puzzles up in 7 seconds. Input and stuff is here. I am actually running the wrong day now that I think about it. So let me quickly change that and we will jump into the puzzle right now. Use the hang glider to ride the hot air from Desert Island all the way up to the floating meadow island. The island is surprisingly cold up there and definitely aren't anything else to glide on. You leave the hang glider behind. Wander around for a while, but you don't find any people. However, you occasionally find sound posts like hot springs, pointing something in this direction. Maybe you find someone in the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. They stop to mark some metal grass. You notice something metallic scurry by their peripheral vision. Jump into big pipe. You didn't look like any animal you've ever seen. Scan the area, discover the entire field you're standing on is densely packed with pipes. It's hard to tell at first because they're all the same metallic silver color as the ground. Make a quick sketch of all the surface pipes you can see. Your puzzle inputs. The pipes are arranged like this. Okay. The ground is starting position. Alright. Based on the acoustics of the animal scurrying, you can confident the pipe contains the animal is one large continuous loop. For example, if the square loop of pipe, if the animal has entered the loop and the northwest corner, the sketch would look like this. In the above diagram, the S tile is still a 90-degree F bend. You can still tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected into the loop. The sketch shows K. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S pipes, those connected to pipes, every pipe mainly connects to two neighbors, including S, which is exactly two pipes connecting to it. Okay. If you want to get ahead of the animal, you should find the tile in the loop that is furthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way. Okay. Find the single giant loop starting at S. How many steps along the loop? Alright. Alright. Yeah, I could have seen this one coming. Huh. Okay. We have to build a loop out of this. Is there only, I'm guessing there's only one loop. So yeah, thinking of how this one's gonna work is gonna be interesting. Is it just enough to go through and just validate pipes? Let's just do this. Let's start with it's gonna equal to input split sorry, I'm doing input split on new line, and then go ahead and map. No, we don't need split. We can do that. Actually, well, we do, but we need to map then the line to then do the line and split on every character. So this gives our map. So here's our map. So we need to know where we're starting. It's gonna equal map. I do need to know where it's starting, right? Yeah, so it's like right there. And then from that, what we do is we find the two directions that we're supposed to be going in, and then we just go in both directions till both directions meet. Right? X equals 0, x is less than map dot length Nope, that's not X, this is Y. Y minus minus. Alright, we're gonna do this on, this is gonna be unfunctional for today, because this is, yeah, it's just not gonna be a functional code for today. Or a functional, yeah. Okay, X, 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 map, Y. Length. And so all we're just looking for is, actually I'm gonna put this in a function, const get starting position. That way I can return out of this. Just so I can start without having to do this. So what we can do is if map y x equals s, return y. Actually, we'll do xy because I like doing that better. Otherwise, return 0, 0. All right. So we have our starting position. So what we're gonna do is and then we're gonna do is let moves is equal to 1. Because we're gonna make another function here called move. It's gonna take in a position, and what it's gonna do is it's going to do this. So we have our position. So what we need to do for the first move, we just have to scan and find the two positions. I'm gonna hard code these. I'm gonna be lazy and hard code this. We're gonna do positions is gonna equal positions, right? Actually, I can do it here. It's gonna be starting position. Zero, starting position 1. Okay. So the first one is going to go down, the other one's going to go left. So down is +1, left is -1. I missed that. Alright, so now we have our positions. So now we can just do a while loop of while positions 0, 0 does not equal positions 1, 0. And positions 0, 1 does not equal 1, 1. While this is going, we have to move each position. So we need to do const position 1. And we can do position 2, just so it's a little bit easier to look at. Okay. So we do need to get, we do need to determine if they connect. And we do need to track where these came from. So this actually is going to be this and that. So we do need a get connecting position 0, position, nope, that's 0, that's 1. So we're at the position, so we need to figure out what connects to it. And that's just going to simply be const up is going to equal position 0, position 1, minus 1. Up, down, left, right. And actually, I'm going to do this instead. No, I do need to do it this way. Making this as a helper method because make my life easier, not to write this out every time. It's gotta be that. So it's while these are not equal, so it's gonna be positions 0, positions 1. Okay. So up, down, left, right. This is fine. I'm just being very inefficient about how I'm doing this. Okay. And so what we need to do is what we need to do is if last positions I do need to pass in last. If are not equal, up and last position, then we need to check the map at up 1, up 0. And now we need to know, this is where I should have kept my list of stuff. Down chars. And F. Oh wait, I did F. What's the other down char? 7. Down char, here's my up chars, here's my left, and here is my right. So up is going to be J and L. Left is going to be J and 7. Oops. It's going to be L. And these are both that. Okay. So up, so if they're not equal, and up is a down char, because that's except one coming from the below. So if down chars includes, we return. What is get connecting supposed to do here? Oh, return the connecting position, which is just gonna be up. So that means I can go here. Okay, and then we gotta check down, 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 down. And this is gonna be up chars. Nope, up chars. And then we get into left, 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 left. That's right chars. And then this is gonna be right, 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 left chars. Okay. All of those, good. Yes, I can also technically. I don't know why I'm doing this. This is a total waste of time for me to be cleaning up like this, but you know. I got out my code looking good for whatever reason. Okay. So now I can do is get connecting on position 1. Oh, it's gonna be last position 0. Okay. So here's our new positions. Moves plus plus. And what we need to do is now we need to update positions is going to equal. Actually, we should be doing last first. Last positions is going to equal position 1, position 2. Is that really all? It feels really weird, but that might be all. Okay. It's good to know that it's not getting there. Where is this erroring out? It's not finding the starting position. Okay. Oh, because I don't understand what I'm doing. Why I put minus minus, I have no idea. Good. Okay. Good progress. Current undefined reading 0. I also need to do a const is in bounds. Position 1 0 is greater than or equal to 0. And position 1 0, actually it should be position is less than, or it actually is less than map.length, but these are actually backwards because this is y first. And then this is this, and then this is gonna be, actually I can just do 0, it's fine. And so now I can just add an is imbalance check to all of these. And also pass the right one in. 26. I got an answer. Well, I got an answer, but then it... Nice. Nice, nice, nice. Okay. Clearly not working. Totally not how you do it. So the position, and then what we do is const char is this, but it's position. Okay. And then we do is if the char, or if no, it's if down chars, and that means they accept it from the bottom. So this character is, so it's, that means we need to go down. That means down's a choice. So actually we should start up chars first. Up chars includes that. Then we do this. Here is up. And we don't technically need the inbalance check, but we're going to do it. Check that they're not equal. And it should be fine. We don't need to check that it includes. Right chars. You don't need to check it. Left, we don't need to check it. What the heck? 73. Oh no. It dropped to 0, 0. Okay, 73. Well, this one didn't go right. Oh, left chars. My bad. Okay. Let's try this again. I got an answer. All right. I just don't know what I'm doing. Apparently, you know. All right. If we reach the furthest point of the loop, but the animal never emerges, maybe its nest is within the area enclosed by the loop. Determine whether it's even worth taking the time to search for such a nest. You should calculate how many tiles are contained within the loop. For example, there's math you can do about this to calculate whether or not something's in or outside the loop. And it's about firing arrays. If you can fire a ray, this is just this. Will it be enough if I can fire a ray off of all 4 directions? If it crosses through the shape an even number of times, it is not within it. If it crosses through an odd number of times, it is within it. That's what I remember from my, I don't even know what class that was. I think it was animation. I can try it. And I can try it with all of the points. It's going to be very slow. All right, what we're going to do. All right. We're gonna yell. I don't know. It's just the very first thing that came to my mind. So we're gonna need a const of positions. So it's just any four directions. Okay. Equal that. We're gonna positions push okay. So what we're gonna do is steal this. So what we're gonna do is let contained equal 0. So we're gonna go through all these and we're gonna get to a point. First we're gonna check is if positions if I do console log position dot includes out of curiosity, does this return true? So if it doesn't, this isn't gonna work. We do need to do positions. Woo! I forgot I never included them. I don't know if it's only because I'm doing it, but I will. Should be a bunch of falses in the very end. We should get 2 trues. I'm trying to validate if this even with JavaScript even does. Oh. Oh wait, whoops. Sorry. We should have gotten trues because we should have gone back to where they were. What we can do though, I can actually do this. I can do a quick method. I can do the quick logic position 0 times map dots. No, sorry, 1. It was map 0 length plus position 0. This should work. I should be able to do this. Please work. Bunch of falses. At the very end, we should get a true. What? This should work. We're gonna hope that this should just work. And I just realized I just deleted what I had written down here. Okay. So what we're gonna do is go through these all. We can do our num is gonna equal y times if it includes num, continue. Otherwise, let intersections equal 0. While actually, I just do a for loop. For let's xx equals 0, or x equals x, while x is greater than or equal to 0, xx minus minus. Plus xx. If it includes it, plus plus. If intersections 2 equals 1, means it's odd, so which means it's not contained. And so we can just do continue. Well, is this? Well, xx is less than it's less than that, plus plus, same thing. But now here we get to yy is y, well yy is greater than or equal to 0. Yy minus minus, yy. Let's do that. And then last but not least, yy again. File is less than map.length yy x. And I think at the very end though we can then do contained plus plus, and I have no idea if this is even close to efficient. Probably not, but this is the first way I could think to do this. Part 1. Oh. Took a second. So close. I thought I had it. Oh, wait, these are backwards. These are backwards. Zeros. I explained it. I did it backwards. Okay, so I guess for this first one. And here's where we need to skip. If map y xx, because this is going left, so if we enter a wall, if we're going left, that means we need to hit a J or a L. No. A 7. Because those are the ones that go left. So if we're going left, we hit one of these, we need to go then while does not equal the other end of it, which is going to be an F well, it can only be a line, so I guess it's going to be then while we are on this, we're going to be doing x minus minus, and then at the very end we get to intersections. We can do intersections plus plus, and we should be jumping one ahead to get into it, and we'll get to out E. Okay. So we just need to add this to all of them. So this makes this one easy because this one's gonna be the same, just the other way around. This is gonna be F and L, but it's actually X plus plus. And then this one's gonna be YY with X, YY with X, YY, 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 X. And this one's gonna be vertical. And it's gonna be, sorry, it's Y minus minus, by the way. So we're going up. So if we hit an F or a 7, no, other way around, a J or an L, and then, all right, yeah, okay, think about that. And this one, the same thing, except this is going to be F and 7 and Y plus plus. If it's in like the 700s, or like kind of in there, like a little less. 42 is not right. There's no way it's 42. Yeah, it didn't get a. This is the biggest thing is, did it get all these in here? That's when we know it's kind of right. I don't know. I guess I'm giving up. I'm giving up a part 2 here. I don't know. Like I've tried it, and I get to like this line right here proves it doesn't work. Is it this line? Yeah, this line right here proves my way of doing it doesn't work, because I get 22. You cross 22 walls to get to the outside. How many? And you cross 4 straight walls. So you came in. Like, I don't know. I don't know. I do not know. And with that being 2 walls, technically, is what I'm counting that as. So I don't know. I don't know how to do this. Audona. Day 10. Failure, I guess. Well, thank you guys for watching. If you guys enjoyed, see you guys next time. Peace. Just kidding. I figured it out. Took me a while. I did look at some answers, but the answers didn't actually help. Well, I didn't use any of those answers. Let's go with that. I looked at them to get some ideas, and eventually I came across the realization that the way I was counting these walls was wrong. The way I was counting like the going through walls was wrong. You only count them as one wall if you pass through it and it actually changes direction. So like in this case, we're not passing through a wall here, or it doesn't count because it's going up, across, and down. You're not, it's not counting because you could, you know, let's just go with that. It's not counting, you're not passing through the wall. Whereas the case of here, L to 7, that's going down, across, down, that you're passing through. So I just went through and changed the logic of my the ray cast to instead, you know, store the starting character, and then when we get to the ending, checking if the ending character is the opposite, or in case if it's not the opposite of our starting character, ignore the intersection, so, you know, decrement or intersection. That gives us to the answer, and that gives us the correct solution. Took a while. I do need to clean this code up because it's kind of gotten to be a mess with all the random stuff I did. But oh my goodness, we're there. Alright, cleaning code up. Go to the talk, answer, explain, 1 minute. Alrighty, day 10, kind of a doozy. The problem, we're given this input of basically pipes and paths. You gotta find where you're starting, in our case here. Given from where you're starting, you have to basically, for part 1, traverse the route and find the furthest position stepwise from the start. So, you know, with one step being kind of one move to one new tile, or whatever you want to call it. That being one step, finding the tile that's the furthest amount of steps away from the start. If you're to traverse in both directions. So, to do today's. It got out of hand. But anyways, first start by, again, just going through and splitting your input, splitting on new lines, and then chunking each line up individual characters. And then from there, there's a bunch of helper methods here. A lot of helper methods. I don't even know where the first logic bit is. It'd be right here. I hard-coded my first 2 positions after the start. Probably shouldn't do that. That's here, but at any rate, for part 1, all you do is traverse it. So, you take your starting position, you go to the next positions from that, and then basically you just go until those positions meet up again. At that point, you're the furthest away you can be. And while you're going, you're basically just taking a position, finding the next position based upon the character you're at. So in this case, I have a map of the characters and which directions they go, up, down, left, and right. I go through all those characters. I say, you know, all the down characters, all the right and left, up. I check those around the position. I don't want to. The explaining is going terrible for today. Just know you're following the characters. So L, you know, going up or whatever. You're following the character's directions. You're making sure you're not going to where you just were. That's what the last positions is here for. Just make sure we're not going to where we were, and make sure we're going next position. And that's pretty simple. We just calculate all the moves, get to where they're equal again. That's part 1. Part 2. Alright, I'm going to try my best to explain this because this is, I'm sure, what everyone really is working about. Is part 2. For part 2, the way I learned you can calculate whether or not a point is inside of a polygon, regardless of there's convex, just regardless of the shape. There's a way you can calculate if you're within a polygon, and that's by firing a ray from your point out of the polygon in every direction. Sorry, not every direction, it's just in one direction, assuming it's a closed shape. It's a closed shape. If it's a closed shape, you fire off a ray from your point out of the polygon. You should cross borders an odd number of times if it's within. If it's outside of the polygon, you'll cross the the border of the polygon or the edge of the polygon an odd number of times, or sorry, even number of times. I can't really draw shapes right now, but just know square. If you're just thinking about it, if you're inside of a square, you go off in any direction, you're crossing the edge of the square one time. If you're on the outside of the square and you're crossing the square, you're gonna cross it 2 times and you'll be back out. So cross an edge an odd number of times, you're gonna be inside of the shape. Cross an even number of times, you're outside the shape. Taking that into account, I go from a point and I go in all 4 directions, and that calculates how many times you cross an edge of the shape. What originally gave me problems though is that you get cases. Does the example, hold on. Example, you get cases where you're crossing an edge, and in this case, we need to be able to calculate whether or not we're inside or outside of the shape. And originally I was just calculating, if we hit a corner, we say, all right, corner is 1, hit the next corner is 2, so no, it's crossing twice, this is outside the shape. That doesn't work. You can't count crossing a corner as crossing an edge unless it changes direction. In this case, like crossing here, start from this point, 1, 2, 3, that would count as crossing an edge, crossing once, because you're only crossing 1, 2. So this would actually not be crossing at all. This would count as 0, whereas this counts as crossing twice. That's what I struggled with, was figuring out from a point, it only counts as crossing an edge of the shape if the corners are opposite. So F is opposite of J because F goes from bottom to right, whereas J goes from left to up. That's hopefully makes sense. Again, I found it easiest just to do that ray casting all 4 directions. It's easy enough because this is just that's an edge, right? Pretty straightforward. It's just dealing with like this point here, how do you deal with these, or this point, how do you deal with this? It only counts crossing an edge if these corners are opposites, as in they take the line in and they go in the opposite direction. So it takes it from the left, but then sends it out in the right. Not if it goes to the left, it's not. Hopefully that was okay enough to explain. Hopefully you get the gist of what I'm saying by that. If you can do that, you're good. I think that's the most intuitive way to decide if a point is inside of shape or outside of a shape. But flood fill, I think, should work too. Should be a way to do flood fill, but you got to be able to support this. So that's why I went with the shape ray casting. But at any rate, day 10 is done. Both parts done. Thanks for watching. Hope you guys enjoyed. I'll see you guys tomorrow for day 11. Hopefully it's easier. Peace out.